Hello, good morning. Good morning. Dr. Sovani here. Hello, hello, hello. Good morning. Hello, can you all hear me? Hello? How many people are online? One sec. Somebody said something? Hello? Kashyap, can you introduce yourself? Hello, Kashyap, can you introduce yourself? One sec. Just call me. I can't hear what these people are talking. Sorry, I can't hear you. Just hold on. I'll get the technician. Somebody's talking there, but I can't hear anything. What is this? Ah, Dr. Kashyap, can you start again? I didn't hear you. I still can't hear you. Friend, I can't hear them.
Just type over here.
But I can't hear them. I should be able to hear them, right?
Just type the, if there's some technical problem, you can hear it. So tell them to type their doubts over here, and you'll explain them through a video.
What a webinar is this? Very bad arguments.
But the time lag is about 5 seconds.
Even then, hello? There's some technical problem. So you can hear me, but I can't hear you all. So type your queries and I will answer you orally. जॉइंट शुगर क्या there is a heavy time lag here. Good, I can see Dr. Girish Kumar has joined. Dr. Kashyap Pandya is there. Dr. Shivani Mishra is there. So you can start putting in your queries. Yes. Please elaborate on null hypothesis and alternative hypothesis. Okay. Um, just reconfirming that you can hear me. If you are not, just raise your hand. Okay. Right. So in statistics, when we start uh, doing the analysis, ideally we should assume that both the groups are equal, or we should say that there is no difference between the two groups, or we should say that no difference because of the intervention we are doing. So that is called the null hypothesis. Null hypothesis says that there is no change because of my intervention. The intervention can be, let us say, it can be some social intervention, maybe addition of vitamin D to oil, or it could be some medical intervention, or it can be intervention about public awareness about AIDS, etc. So when you're comparing the group which was given the intervention and group which was not, you will start by saying that my intervention has not caused any change. That is called the null hypothesis. Now, when you get the answer, if you find that there is some difference, then if there's a difference, then you say, I'm rejecting the null hypothesis and I'm accepting the alternate hypothesis. So what's the alternate hypothesis? That there is a change because of my intervention. That's the alternate hypothesis. And in statistics, when we talk of amount of significance, we are trying to measure the amount of the change because of the intervention. So null hypothesis says there is no change because of intervention. Alternate hypothesis says there is a change. So if I give an example, let us say drug A and drug B. My null hypothesis says there is no difference between the two drugs, drug A and drug B. The alternate hypothesis can be that drug A and drug B are different, or drug A is better than drug B, or drug B is better than drug A. Okay. So alternate hypothesis can be worded the way you want, and if you depending upon what wording you use, you are going to use the different statistics. So suppose I say that both the drugs are equal, A and B are equal. If that's my alternate hypothesis, then naturally I will require many more patients to prove my hypothesis, because the minimum difference, the less difference you want to detect, the more patients you want to have. Okay. Or if I say A is better than B, then it becomes a one-tail test. I require less number of patients. Okay, so based on what I talk in my alternate hypothesis, then I can use the statistics required for that, the test I required for that. Okay, fine. I hope that clears everything. I go to the next question. PS PSUR flowchart. Dr. Preeti not here. What about the rest? Okay, Shivani Mishra can hear, Kashyap Panda can hear, Girish can hear. Okay, good. So I think let us continue then. Dr. Preeti can't hear, so I won't take her pace your question right now. The next question is VG flow. The next question is a VG flow. Now, what is VG flow? It is the software used for Pharmacovigilance program of India. Now, for say, for example, in pharmacovigilance, normally people use programs like Argus or you know, AERS, Oracle AERS, etc. Now, this VGFlow is another customized software which is being used by the Pharmacovigilance Program of India. And the advantage of this software is that it can be easily linked to the Uppsala monitoring software. We can update data from this into the Uppsala monitoring software, and we can analyze all the data from India as well as whatever additional data we want from abroad. Okay. So all the adverse events which are reported by different centers, because if a doctor reports an adverse event, he can either send it by mail or fax to the numbers given, or he can send it to the local center. Local centers will collate everything and send it to the center. They upload it directly into the VGFlow. And once it is in the VGFlow, by the way, when it's being put in the VGFlow, it also has a system where it can automatically clean up the data. So if you find a mistake in the entry of the data, if there's a discrepancy, the system can ask questions and you can correct it. So then correct data is entered into the system, and that can be used for analysis of the data nationally and internationally. Is that okay? Okay. Dr. Shivani, your question is about PSUR. First of all, what is PSUR? It is periodic safety update report. PSUR. Now this has to be given to the drug authorities depending upon their mandate. So the drug authorities will ask you to submit PSURs for a product, or maybe once in 6 months for the first 6 months, first 2 years, then once a year for the next 2 years, and then once in 5 years for the remaining life of the product, etc. Okay. So this mandate differs from country to country. So but basically all countries will ask you for more frequent data for a new product in the first 2 3 years, and then the frequency reduces. Ultimately, for old products, it goes once in 5 years. So whether a 10, 15-year-old product, it is once in 5 years. So Dr. Preeti, I'm already talking about PSURs. Okay, so that is about the mandate of PSURs. Now the question is, what do you want to put in PSURs? So in PSURs, you will start with the first few pages will talk about the administrative data. That is, what is the birth date of the product? The birth date of the product is when was the product first internationally launched. Then you talk about when was it launched in our country. Okay, and then you say how many patients must have been treated. So what is the exposure of the product over how much time? Okay, so you will talk about PSUR from which date to which date. Say from Jan of 2016 to June of 2016, 6 months data. Okay, Preeti, I'm talking about the same thing. I'm telling you what is a PSUR and how a PSUR is created. So it's administrative data, and the first few pages talks about the when the product was launched, what is the period for which the PSUR is given, etc. Then you also given us executive summary, second page, that you say how many adverse events were noted in this particular cycle, how many were related, how many were not related, and then you talk about how many adverse events were found in other countries apart from your country. What is the total number of adverse events noted? That is the information. Then there's one section in PSUR where we call it white papers. White papers means if there is a product which is suspected to have caused some adverse events, or you say suspected unexpected serious adverse events, then the medical director of the company makes a review of the whole case in detail, step by step, and analyzes whether it really could have been caused because of this product. So he will analyze about what was the case, under what condition was it being given, what were the concomitant medications. So he will analyze everything and say, okay, was the side effect really because of this product? And if it is because of the product, then what steps one has to take? How serious is it? How much is the risk? Is the risk life-threatening? Do we need to withdraw the product? Or do we propose that we make a change in the package insert? So all these discussions are taking place here. So what actually he's doing is he's analyzing each case one by one. After this, next section would be risk analysis. So based on the data which you have got from your country and from other countries, you see if the risk of the population increases because of the product. Suppose some new side effect has come which is life threatening, and you feel that the frequency is too high, but at the same time the drug is so important that you cannot stop it. Then what will you do? You will put it in the package insert as a black box warning saying that this is a problem with this product, and without doing this, don't do this. For example, clozapine. When clozapine was launched in 80s, What did they notice? That the drug causes blood dyscrasia. At the same time, it was a very good drug for negative symptoms of schizophrenia. That was the first drug at that time. So then they said that if you give clozapine, then do analysis of the WBC count every 15 days. And that was put as a box warning. That's how you make the doctors aware of the new adverse events. So PSUR is basically what? It is a risk analysis of the product based on the new data which has come over the past period. And after analysis, what do you do? Risk mitigation. It is risk mitigation plan. If there is already some plan in place, you say, okay, this was already the plan. This is how it is implemented. And for the new adverse events, there is a further new plan. So in the throughout the life of the product, this goes on. That's a PSUR. In fact, as per the EU notification, as per the EU notification of 2012, they changed the name of PSUR to PBRER. PBRER would be periodic benefit risk evaluation report. PBRER, periodic benefit risk evaluation report. Okay, so actually from PSURs, we are converting ourselves to PBRERs. And in PBRER, what they have done is they have put the onus on the company. They have said company has to analyze the risk, company has to give us solutions to the risk, company has to tell us how it is to be implemented, etc. So all the onus is now on the company. Okay, so I hope that answers your question. Okay, who else has come? Shashi Rekha. What would be the ideal sample size for a randomized trial, clinical trial control? Okay. Sample size would depend upon a few things. One is the observed standard deviation or observed variation in the results which you can find from currently available published data. Okay. Second, it will depend upon what is your alpha, which is normally about 0.05, and what is your beta. Beta is the confidence with which you can identify the difference. Normally it is at 80 or 90. So you take 1 minus beta in the formula. So you find in the any formula, the alpha, the beta, and the standard deviation sigma are in the numerator. And the denominator says what is the clinically acceptable difference. What is the clinically acceptable difference which a doctor will accept? Say, for example, in case of anti-cancer drug, today the lifespan increase or increase in expected lifespan after having after having cancer with the currently available products is, let us say, 5 years. But this happens to people who are only 40 years old. So at 40 years old, if a person gets only 5 years life and he has to plan for his whole family, it is bad. Now if I got a new drug which gives him 6 years life, that means 1 year extra life, at 40 years maybe it's good for the person to get 1 year extra life. The same may not have been true if the disease was happening in 65, 70-year-old patients. So if you ask a doctor, he will say, yes, even 1 year extra life in this patient is good for me. So the denominator talks about the clinically acceptable difference which has to be found in the clinical trial. The smaller the difference, larger the sample size. Larger the difference, smaller the sample size. Okay, so you will not really answer the question of ideal sample size by just saying what should the number be. You have to find the number based on the alpha, the beta, the sigma, and in the numerator, and denominator will be the ideal difference you want to identify. Okay, there are of course some ballpark figures. Like people say that if you are doing a very small trial, you can have up to 30 patients, or if you are doing a randomized trial about with a medium level of difference, about 100 200 patients are good. There was one reference in BMJ many years back which said that in any trial, if you go on increasing numbers beyond 300, the it plateaus off, the advantage plateaus off. Okay, so I hope that answers. Dr. Preeti Desai still has some questions. I think Dr. Desai answered everything here. I already told you schedule. I started by telling about schedules. The planning is how you have to collect the data to make, and I also told you how you plan the first section, second section, third section. So planning, development, approval is done by the DCGI. Actually, there is no approval. You just send it to the DCGI, he accepts it, and you don't have to distribute it. You have to only give it to the government, nobody else. Okay, so I think I've answered all your points. Okay, I'll go a little further on distribution. You see, each country has got a different schedule, as I mentioned earlier. Some countries say twice a year in the first year, and then once a year after the next 4 years, and then once in 5 years. Some countries say 6 monthly for 2 years. Correct. So what would happen is if there's one responsible person, pharmacovigilance person responsible in the company, he has to keep track of all the different countries and which country when you are supposed to submit the PSUR. Correct. There won't be really much difference between the PSUR because only a 1 month's 15 days data may have to be added here and there. So he will have to make those minor changes and actually submit the same thing to different countries. In Europe, for example, they have made it simpler. What they have said is that if you have a common uh, clearance from EU rather than from a country, then you can send the same PSUR to all the countries, or you can load it into the EU system. You can load it into the EU system, and each country has access to that. Okay, I think Dr. Desai, you're happy now. Okay, Shirish, Shashi, Rekha. In a given study, how to decide whether we have to apply a parametric or non-parametric analysis? Is it depend on sample size? No, that's not. Now, say for once upon a time, people used to say that if it's a small sample size, use non-parametric; large sample size, use parametric. But that's not really true. Uh, Depends whether the data falls in the normal distribution curve. That is important. If the data falls in the normal distribution curve, if the data is normally distributed, it is parametric. Then you use parametric tests. If the data is not parametrically distributed, it is non-parametric. That is one. Number two, for interval data. By the way, I am a bit slow in talking. I stop in between because I am hearing my own voice after about 5 seconds later. So I let that die down before I start talking again. Okay, so I'm sorry about that. Yeah. So the non-parametric Okay. So we were talking about uh, parametric and non-parametric tests. As I said, data which is falls in the normal curve is parametric, for which you have to use parametric tests, and what is not normally distributed, you use a non-parametric test. Another way of handling that would be that data which is interval data, which is in the continuum, like blood pressure, like blood pressure, or height of students, or weight, where you've got discrete numbers, where you've got interval data, and a continuum, it is parametric. If you're using nominal or ordinal data, where you're talking of stages of cancer or improvement in pain, mild, moderate, severe, okay, then that is non-parametric. So when you've got interval data, parametric. All the nominal ordinal data, non-parametric. That is one way of looking at it. Secondly, distribution of data, normal distribution, parametric. Non-normal distribution, non-parametric. Is that okay? Understood? One more question. Okay, disproportionality measurement. Give me a sec. I'm just sending one message to someone. I'll answer you. Huh? Just a minute. Yeah, sorry. Oh my God, there are three questions come. Okay, let me take them quickly one by one. For disproportionality, I will give you a simple example. Let us say a product, okay, causes some adverse event. Now, what you are going to see is what you are going to see is in normal population, what would that number have been, and how much number am I getting because of my drug? Excuse me. Sorry. The example I'm giving you is this. Because of one rotavirus vaccine many years back, within the first 1 year of launch of the product, there were 11 cases of interception in the population. And the cases were all bunched together to the administration of the drug. That means soon after administration, within 2 months, the patient got interception. Now, what was done was they looked at the incidence of interception in the population, and in the population, what is the spread of the disease? That you get 11 cases in the population, but you get them spread evenly over 11 months, over the whole year. Whereas in this case, after giving the vaccine, within 1 to 2 months of giving the vaccine, the case happened, and they all got bunched up after the administration of the vaccine, after launch of the product. So this is disproportional. So that's the disproportionate analysis. So you measure the difference between what is noticed and what actually could be expected in the population, and see the difference, and that is disproportion. If you find that, that means there's a signal. So in this particular case, the particular drug was withdrawn from the market because the company said that this is too close after administration of drug. So even if within the population normally 11 or 12 cases would have happened in the year, and our drug also is given the 11 12 cases, still it is too closely related to the administration of drug. So we suspect the drug is a cause, we'll withdraw it. Okay. Okay. So I think this answers Shivani Misra's question. The next question is one way and two way ANOVA. You see, normally if you ANOVA generally is a parametric test. So if you are doing a parametric test, normally we will either use a t-test, paired t-test, or unpaired t-test. So if you have got two groups, you would use a t-test. If you've got three groups, you would have to use a t-test how many times? A, B, A, C, B, C, three times. If you've got four groups, then you have to use the same t-test six times. Now you know that we have set the P at 5%. That means if you repeat the t-test 20 times, at least once, you will get a significant answer by chance. Correct? We don't want that to happen. So if you've got more than two groups, use a ANOVA. So for example, I'm giving an antihypertensive drug and I'm testing the uh, change in blood pressure from baseline at week 1, week 3, week 5. So what am I doing? I'm doing week 1 minus week baseline minus week 1, baseline minus week 3, baseline minus week 5. And whatever averages I get, I compare them with the baseline. Whatever difference I get, I compare with the baseline. It is baseline against 1, baseline against 3, baseline against 5. I do different t-tests. So I have to do three t-tests. I don't want to do that because, as I said, there's a flaw in the whole system. If I use repeated t-tests, I could get a significant answer by chance. So I use ANOVA. ANOVA is a helicopter view. Helicopter view, which first tells me, is there a difference overall in this whole data? The F value tells me, is there a difference? If there is a difference, then I will use post hoc t-test to find out which two of them are different. Okay, so that is one way ANOVA. Now, if I add more criteria to that, in the same data of difference of blood pressure at week 1, week 3, week 5, I split it into, categorize it into males and females. Then what happens? Effect of the drug separately on males, separately on females. I have to see is it different. First, I have to find a difference from baseline, whether it is significant. Then between male females, it is significant. I can make one more classification. Elderly, not elderly, less than 40, above 40, below 40, or above 50, below 50. So now I have one more classification. So it is week 1, week 3, week 5, male, female, within male, female, above 40, below 40. So imagine it's like a Rubik's Cube, on one parameter on one side, and they all interact. It's a multiple way ANOVA. Okay, so one way ANOVA is just simple one dimensional, multiple way is multidimensional. Okay. Yes, Dr. Desai. Regression. Regression analysis is simple. You know, in college you have learned that formula for a straight line graph. What is that? Y is equal to ax plus b, correct? Okay, I think I'll hold on for a minute. Dr. Shivani has understood. Dr. Rekha may be having some questions, so I'll wait for her to say yes or no, then I'll go ahead. Not answering, so maybe she's understood. Okay. Okay. So I'll go. Yeah, she's understood. Good. So now next, regression analysis. Dr. Desai, regression analysis, as I said, is based on the same old parameter y is equal to x plus b. So what does that mean? That if you have got a straight line graph, hmm, you have got the value of x, you can calculate value of y, correct? So in regression analysis, if you have got value of one parameter, you can find the value of another parameter. That's the most simple way of explaining that. To make it more complicated, there could be many parameters affecting the same thing. So how much will this parameter affect? And that is all. That is called multiple regression. So you have got simple regression, y is equal to x plus b, and multiple regression. There are many parameters coming in. Let us say for heart disease, you have got obesity, you have got smoking, you have got drinking, you have got so many different parameters, tension, lifestyle, and each one, how much is it going to affect the heart disease? What proportion of the heart disease is being affected by one of them? So if you want to find that out, that's called multiple regression analysis. Okay. So you've got simple regression, multiple regression. Is that okay? Okay. Now next, criteria for a signal. This is a difficult one to answer. Basically, when do you call something a signal? Something which is suspected, unexpected, adverse drug reaction. So now, for example, when you're collecting data, you do disproportionate analysis, etc. Ultimately, what are you doing this for? You're trying to find the causality. We are trying to see whether our drug is the suspect drug. And once you come to that conclusion that yes, your drug is the suspect drug, and this particular adverse event is not known to you, so it is suspected, unexpected, then that's your signal. The method of getting a signal could be different. You could get a signal from some journal reference, you can get it from your computer analysis, or even a data entry operator, if he's smart enough, he can he can indicate that I am getting this new type of complication, new drug interaction with this product over the past 2 months. I've filed 5 cases. Okay, so anybody can raise a flag. That's a signal. Now, once you get a signal, what do? You try to analyze it. You say, okay, is it how strong is the signal? Can I directly conclude that yes, this is because of this product, and I need to take some action? Or should I say I want more data? So suppose you say you want more data, then what will you do? You will either go back to journals, do some journal search, or you might create an animal model of the disease and try to do some more animal experiments, or you can tell all your company representatives to collect data on that particular adverse event. We call it flagging. So you're deliberately collecting data on that adverse event more so that you can analyze more number of cases. And by doing this, you're trying to verify the signal. You verify the signal, you confirm the signal, and then finally you take action. Okay, I think that should be sufficient. Okay, now Dr. Desai, I think is looking at slides one by one and asking questions on each slide. What is Pearson's correlation? Regression I answered. Now correlation would be, okay, so correlation would be Is one related to the other? Is A related to B? Like say, let us say I go to a factory and I ask them question. I ask there are 50 workers in the factory and they are manufacturing something, and the manufacturing output is re- reported every day. Okay, per worker, I know what is the output, which is being given to me by the supervisor. So I take a questionnaire and I talk to all the workers and try to find out how much of job satisfaction do they have. So now I got data on job satisfaction for every worker. The supervisor has given me the productivity data of every worker. Now I try to see whether job satisfaction is related to productivity. So if I get a correlation coefficient of say 1 or 8 to 0.8 to 1, which means that there is a very strong correlation between job satisfaction and productivity. So a correlation coefficient of zero point 0.8 or 1 is very strong. 6 to 8 or is say moderate or mild. Then 4 to 6 is mild. 0 to 4 is not so strong. Okay, so that is correlation. Now, different correlations, you can have correlation coefficient of Pearson and there are many others, but the principle of correlation is this. Okay, good. Anything else? We got only 4 students today. I thought there will be many more. This is a new question. Chi-square can be for parametric and non-parametric. If yes, when do they apply? Okay. This is another tricky one because normally when you are having observed data, expected data, then we can apply chi-square test. Okay. So basically it should be observed and expected data. So in case of non-parametric data, let me give an example. In case of non-parametric data, you're talking of what? Uh, Change in the pain response over time. So initially, everybody had a pain response of severe. So it's absent, mild, moderate, severe. 0, 1, 2, 3. Everybody was on 3 when the drug was given. And then over time, they came down to 1, 0, 1, or 2. Now this is a ordinal data. So what will you do? You'll use a sign rank test. You say, okay, difference in patient 1, 3 minus 0 is 3, 0 minus, then next is 3 minus 2 is 1. And that way you put down the difference. And you say total difference is so much. So observe, that is the observed difference. Now, what is the expected difference? So if you expect that your product is extremely effective, you will say everybody from 3 should have come down to 0. So my expected difference for 10 patients would have been 30. But here my observed difference is only 15. So observed minus expected divided by expected, I use the formula and I use a chi-square. That is one way of doing it. In case of parametric data, again, if you've got fixed numbers, let us say in epidemiology, you've got fixed numbers that I got I have observed so many cases of chikungunya in this city after giving uh, public awareness programs. I got the past data based on the past data, I would have expected so many cases to come. So observed cases, expected cases divided by expected. So here when you got such data, whether it's parametric or non-parametric, you can use chi-square. Okay, chi-square is generally whenever you have got observed observation, expected observation, and you want to find the difference. Okay, so going back to my chikungunya example, let us say my chikungunya incidence is new cases in the past 6 months in this particular city of say Surat or Ahmedabad, or we take anything your choice, is say 10 per 1,000 population. Then we give public awareness programs, we do fumigation and etc. And then in the next 6 months, it comes down to 4 per 1,000. So my observed is, and I noticed that earlier, if I had done only fumigation and left it to the people, not done any planned this thing, it would have come down to only 8. So my observed is 4, expected is 8. Is there a difference between the 4 and the 8? Is the difference because of my intervention? What is the intervention? Public awareness program, telling people not to keep water outside, etc., etc. So that makes all the difference. Okay, good. I'm glad I can answer everybody today. I didn't know I was such a good teacher. It would have been better if I could have heard everybody. I would have done much more work. Yes. The question is when chi-square is to be used and when ANOVA is to be used. Is it when more groups are there, ANOVA is to be applied? No, not really. Even if you have got 3 groups, you can still use a chi-square. You've got 4 groups, you can still use a chi-square. If you are only talking of small data with observed and expected observations. Okay, but ANOVA is used when you want to avoid doing repeated multiple tests. In case of chi-square, even if there are 4 groups, you can still use one test. Okay, so now let us say, again going back to the example of my blood pressure, when I had one way ANOVA, I tested the same patients on 3 occasions: week 1, week 3, week 5. When I had multiple ANOVA, I said week 1, week 3, week 5, male, female, above 40, below 40, correct? And then that was the same data. If I had not used the ANOVA, I would have had to do t-test maybe 50 times. I didn't want to do that. So I used an ANOVA. Even in case of non-parametric data, you can use Kruskal-Wallis test for the same purpose. That you don't want to do uh, Wilcoxon test again and again and again. Like a Wilcoxon test in non-parametric is like a unpaired t-test, and Mann-Whitney test is like a paired t-test. These are the most simple tests in non-parametric. When you don't want to do them repeatedly, then you will use a Kruskal-Wallis, which is an ANOVA in non-parametric. Does it clarify? Only two people are seem to be asking questions. Where are the rest? Dr. Girish Kumar has not asked anything. Dr. Pandya is not asked anything. Dr. Shivani has not asked anything. This particular WebEx have got a lot of glitches. Normally, one should be able to see how many people are online, etc. I'm not able to see that. If somebody left the webinar, I have no way of finding that. It's a little bit crazy. This is there are 6 viewers. I'll wait patiently. I can wait for some more time. If you feel that now all your questions are answered, then one by one you can sign off and then we can close. Okay. Ah, good. A new person has come. Power of a study. All powerful questions are coming. Power of a study. I would really have liked to hear everybody's voice and interact with you so that I could have explained better. Okay, but now that I'm talking one-sided, uh, 1 minus beta is the power. Okay, so I need to go to type 1 and type 2 errors first. So what is the type 1 error? That null hypothesis is is accepted by chance. So we put it as 5%. Okay, that means what happens is that there was actually no difference between two drugs, but we found a difference by chance. Hmm? So that was we put it at 5%. It's alpha error. And the other way, that there was a difference between the two drugs, but we missed it. Okay. Now here people keep it more than 5%. People normally keep it at 10 or 20%. Okay. So imagine like this, that we say that a person is not is innocent until he is proved guilty. Correct. So similarly, for a product, we are giving a full chance of being proved first before saying it is good or bad. So what we do is that to accept the hypothesis by chance, we keep it 5%. And to reject the hypothesis, we keep it at 10 to 20%. So we don't mind becoming more strict with the product. Even if there is a difference, we'll say there's no difference until we get a very strong evidence. Okay. So that is beta error. So then reverse it. If beta is say 10, then power is 90. So if 10 times out of 100 I reject a good product, I reject there's a difference, but I say there's no difference. Then 90 times out of 100, I will catch the difference. Okay. So the 90 becomes my power. What is the strength with which I will be able to detect the difference? So if the doctor clinically says, clinically, I don't mind if the patient of cancer lives 1 year extra. Okay, so 90 times out of 100, if I repeat the trial 100 times, in 90 trials, if the patient is really living more than 1 year or more extra, I will catch it. And 10 times I might miss it. It's okay. Okay, so the power is 1 minus beta. And again, as I said, that 1 minus beta is in the numerator. So I'm answering Priti Desai's question now. 1 minus beta is in the numerator. So if whatever is in the numerator, if it increases or decreases, my sample size becomes bigger. Okay. In case of power, if my power is say 90, my sample size is bigger. If it's 80, my sample size is smaller. In case of psychological testing, when we do say non-drug related qualitative analysis, sometimes they set the power at 40, at 60. So the sample is still small. You'll find the tests are all 20, 40, 30, 50 patients. They don't talk of 100, 200 cases. But in case of drugs, we have high power, 80, 90. If it's 80, you might require 300 patients. If it's 90, you might require 500 patients. Okay. So Dr. Roy, Dr. Desai, have I answered you? Dr. Desai, I think we spoke about this earlier also. That for sample size, always see what comes in the numerator, what comes in denominator. What is the numerator will always increase sample size. What is denominator will always decrease sample size. Okay, smaller denominator, bigger size. Larger denominator, lesser size. Inversely proportional. Please explain what type of study you are talking about. When you say in vitro study, what type of test are you talking about? Let us take a specific example. For others' benefit. Oh, but anyway, you can see that whole chain, right? The question is, in vitro study, what is the minimum sample size required? See, as far as I understand it, this in vitro study can be done during say, analysis, dissolution studies in the factory. It's in vitro study. It's a lab study. Or you do analytic analysis of different samples. So you're injecting, okay. Dr. Shivani, I'll answer you. Let me finish Dr. Desai's question. So it's a lab study. So anything which you do in the lab is in vitro. And in vitro, ideally people like to have a sample of 5 or 6. Actually, now people say, why was 6 as a chosen as a sample? Because once upon a time when there were no computers, that time if you wanted to find the standard deviation, then the formula of standard deviation was sigma x minus x bar the whole square upon root n minus 1. So that n minus 1, if you take 6 patients, n minus 1 becomes 5. It is easy to divide. So that's how people took 6 or 11 cases for in vitro studies. Okay. For all these lab tests, if you notice, resolution apparatus always has 6 buckets or 10 buckets. So people say we use 6 buckets, or we repeat it 6 times. So the sample size in vitro study is not really patients, it is how many repetitions you do for that particular trial. Okay. Now Dr. Shivani has asked a very broad question. What is medical writing? Now, Dr. Desai, is it okay? Have I interpreted your question correctly? Fine. I'll go to Dr. Shivani's question. In any writing which is specifically done for a particular area is called technical writing. So you can have technical writing for engineering, you can have technical writing for say astronomy, or for rocket science. Okay, so what you're doing is you are using terminology for known only to people of that group. If I'm talking of say engineering, I'm talking within engineering, I'm talking of development of elevators. Okay, so what type of elevators, high speed elevators, etc. So you're using then you talk of different types of brakes used in elevators. So the terminology for elevators is known only to people who handle elevators, correct? So when you write technical stuff about a particular area, that becomes technical writing. So if you're writing something about the medical area, that becomes medical writing. But now within medical writing, as would have been the other cases too, what you can do is you split it into regulatory writing, writing for journals, writing for the layman, and writing for marketing. If you're writing regulatory writing, then you follow all the rules given by the regulatory authorities saying how to compile the data, what minimum information you have to give, how you have to present the data, etc. That is regulatory writing. Writing for journals. Now in case of regulatory writing, you're writing to technical people about your product. They could be doctors, they could be non-medicos, they could be manufacturing people. So you have to word it that way. For journals, you're writing specifically for doctors. So your style of writing is different. You're not using unnecessary phrases. You use minimum phrases but give maximum information. And then you prepare it the way the journal wants. So some journals say first page should have author's name and all the attachments, etc. You should have a name of the person whom should be contactable for with questions. Then they say you write the matter separately and the table separately. You give references in a particular way, Vancouver style or APA style or some other style. So you follow that rules. That is medical writing. You can write for a layman, which is the absolutely simplified terms, or you can write for marketing, where you're talking to uh, say layman, but in a different. Say you're talking of say nutraceuticals. You're talking of Chyawanprash. So how do you put a Chyawanprash ad in the papers? So that is a different style of writing. So medical writing is again divided into regulatory, journal, uh, marketing, and layman writing. Okay. Okay. So have I answered you, Dr. Mishra? Okay. Sir, in India, how is ADR recorded? If you go to the DCGI website on pharmacovigilance, they will give you a form, a red colored form, where you have to mention all the information about the patient and submit it to the telephone numbers given there, or the fax numbers or the email address given there. Okay. Now, when you record information, normally what information do they ask? What are the four basic what are the four basic requirements for a adverse event to be recorded? You should have a patient, you should have an adverse event, you should have a drug, you should have a reporter. So for all these four, they will ask information. So information about the patient, information about the adverse event, information about the drug, information about who is reporting. All that has to come in that form. You fill up the form, put it on the email, and it goes to BG Flow. So about the patient, they will ask you identifying questions, but then they will, uh, when you analyze it, the patient identity will be not disclosed. So patient's age is required, sex is required. This is required because you want to analyze the data afterwards. Age, sex, weight, and other data. Okay. Then about the adverse event, adverse event, they will say, okay, what was the adverse event? How serious was it? Then what happened to the patient afterwards? Was a drug given again? What happened after re-challenge? What other drugs were used? Concomitant medications? What other disease history was there? So there is patient and drug information. Then what dose of the drug was used? What formulation was used? What was the batch number? That is the drug information. And who is reporting? Doctor, whom can we contact for more information? Okay, so all that is covered in the ADR form. Nothing more. As you log out, please put a small note saying I'm logging out, so I will know who is there, who is not there. Okay. Role of pharmacist in ADR. A pharmacist is generally the reporter. So he certainly is a part of ADR. In fact, for an adverse event can be reported by anybody. It can be reported by a health worker. So health worker would be a pharmacist, a nurse, a doctor, surgeon, anybody. And it can also be a layman. For example, in USA, UK, Australia, there are systems where a layperson can call up a office number. A layperson can call up an office number and say, "I'm taking this drug. I got this side effect." So everybody is a part of adverse event reporting. It's right from the layman to the topmost doctor handling the drug. Because the whole idea of adverse event reporting is to generate signals and make the drug safer for the population. Okay, now Dr. Mishra is asking a question. She said, "What's the job of a document publisher?" We had got an email regarding vacancies at Quintiles. Okay. Now, different people give different labels to different jobs. So I do not know what Quintiles had in mind. But say, for example, I was in TCS. Uh, Anybody who compiled everything, checked all the data, compiled all the data, was a publisher. Or somebody who checked it and took a final decision to upload it, he was a publisher. Okay. Or sometimes there are people who only annotate the data. You put different tags in PDF. He also can be called a publisher. A person who writes is a medical writer. A publisher is generally not a medical writer. He is only handling the data. So a document publisher, to my mind, would be somebody who is working in the regulatory area, who is compiling the data, analyzing data, checking for correctness, and uploading it. But he is not a medical writer. Labeling, is it medical writing? What part of labeling are you talking about? Labeling would actually uh, be regulatory work. Again, as I said, people use different terminologies. When you say labeling, are you talking of the carton label of the product? Then that is pure label, purely a regulatory work. Are you talking about the package insert? Then that could be medical writing in regulatory. Okay, so depending upon what people consider as labeling, your profile would change.